enough about us. Phil, let's talk about what it is that we've come here to talk about, specifically marine best practices. We want to help the audience build the best marine system, not just Kicker, but the best marine system possible, hopefully with Kicker. So,
right. Yeah, lots of these things we're going to talk about today are not brand specific. They apply to the application. We're going to do this. We're going to do this no matter what brand of audio product we're working with.
Okay, so let's start with key offenders. Now, if I want to add an amplifier to an existing audio system, maybe there's already a radio there, or if I am going to just put in a radio and an amplifier, let's talk about the basics. What do we do?
Let's talk about those as two examples, because most boats do come with a stereo installed. Typically, it's what we call a deck and four. It's radio, and it's 4 speakers connected to the radio. In that instance, as delivered from the boat factory, that system is going to work fine because there's one voltage source that the radio is getting power from. Your other scenario where you're adding an amplifier or you're adding a radio and an amp, that's where you have the potential to run into problems, because your boat's wiring typically has the radio connected to the wiring that goes to the helm, as you see in the PowerPoint presentation. But your amp is going to be wired straight to the battery. And because of those two different points where we're getting our power and our ground, we can run into a voltage potential difference that will end up as noise on our RCA cables.
About a year and a half ago, I was in Amsterdam, and we were training a new marine customer, retail partner for us there. And while we were doing the training, a customer came into the store, and he had recently purchased a new boat, and it had a factory installed radio, amplifier, speakers, and he was complaining about alternator noise, whine, and hum. Factory installed system. How does that happen?
Well, the boat builders are very cost conscious, and they're quite aware of the cost of copper. They also they don't have the experience that we do as Kicker with our Tech Force group, with all the history that we've got with the marine audio forums online. The problem lies in the fact that they are doing what they've always done. They're using the power that they get from the helm to power the radio. The problem with using that power is, if you see all the other items on our PowerPoint slide we see here, we've got the tachometer, you've got a multifunction display, you've got your trim pumps or your wake shaper pumps, and those are actuated by a solenoid, and all of that stuff is powered from our helm power wiring. And all of those things create noise whenever we have a radio wired to that and an amp wired to the battery.
So in this scenario I just put forward, the simple solution for that gentleman would be what?
What we would want to do, in simple terms, is take the radio's power wiring, the red connection, here we go, and the ground connection. And if you've got a radio with a memory lead, the yellow wire, you want to remove those completely from the helm wiring and reroute them by some means to the same power point that we're drawing power from for our amplifier.
So we take that OE system, and this can apply to anybody who's in the audience right now. If you have a factory installed audio system and you're having noise challenges, what Phil is saying is the first thing to try. Don't swap out equipment. Try this rewiring first, because it could be as simple as a voltage differential between your source unit and your amplifier. Does that sum it up, Phil?
It does. And we don't have to go into the weeds on that, but okay. When you've got a voltage potential, that creates a current potential, and that allows AC signal from all these offending noisy things to be modulated onto your signal connections.
Something you and I were talking about when we were practicing this is noise isolators, and you have a pretty strong feeling about noise isolators. Can you talk about that for just a second?
Yeah, and I should have brought in a prop. They're Band-Aids. Okay. Ground loop isolators seem to fix the problem, but they don't fix the problem. They just isolate the problem. The problem's still there.
Okay. So the best practice. I'm sorry, Phil. Go ahead.
No,
I was
you
gonna
go
say
ahead.
the best practice would not be to use the isolator. The best practice would be to rewire it like we just discussed. So take the isolator out, throw it away, recycle it, rewire the audio.
Correct.
Okay, wonderful. Dash rocker switch. Tell us about this, please.
Okay, yeah. So in many instances, we're going to have people wondering, okay, how do I maintain the functionality of my radio now that I've removed it from the helm wiring system? And this is a graphic example when we look at the PowerPoint of how we can tap the distribution block, in this instance, coming from the battery that feeds the amplifier. We can tap that at a fused point and go through the existing dash rocker switch that exists on many boats to turn the radio on and off.
So you're suggesting that we can use the switch that's already there, but just rewire it to a cleaner power source for the audio.
Correct. In effect, you go in there, you find your power wire to the radio, you chase it back to that switch, and then the other connection obviously is going to be from your helm power wiring. You disconnect that, cut it, crimp it, seal it, make it so that it's not a fire hazard, and then pull a fresh power wire over to the input to that switch.
I like that you brought up fire hazard because we're going to touch on that a lot later.
You bet.
But something else that some of our non-boat guys may be wondering about is why is there yellow and red and not black or blue and red? Why is there yellow in that image?
Many boats today have the accommodation to be plugged into shore power. And so on that boat, you have both DC systems like we're used to, but also AC systems. And black wire that normally is a ground wire for a 12-volt system, on a boat, the black wire for the AC system is 110-volt hot side. And so by color code, it's easy to get confused about what you're connecting to. So the ABYC, the U.S. Coast Guard, has implemented, I don't know, 6-7 years ago, the color code of yellow for DC ground.
So if you're in a boat and you see yellow, that is your audio ground. That's where you want to be working with for your audio system as ground.
Yes. Now,
Okay.
black is still allowed, but in those boats where you see a black ground wire, of course, there's a lot of used boats out there. You just got to take the time, use your multimeter, figure out what you're really getting ready to hook up to.
That's a good point, Phil, because the guy before you, he may have used yellow because that's all he had left, but that's actually the hot wire, the power wire.
Yeah, and our car stereos, you know, your typical car stereo's got a switched power red wire, you've got a black ground wire, but ding ding yellow is your memory wire. So it takes a little bit of thought in every instance.
So there's no substitute for basic practices using a multimeter.
Correct.
Awesome. Anything else about this picture that's important for us, or should we move on?
Well, key to note while we focused on the rocker switch and rerunning the power wire, note also as you look at the funny long path around, we've rerouted the ground wire as well to the same place where the battery ground is being distributed.
So that's this wire here that I'm using the highlighter on. That is the ground wire. Or no, I'm sorry.
Yes.
This one here, the yellow one. Yeah, yellow one.
Yeah.
That's our power. Okay.
Oh, yes. Yeah, the long around one is the remote turn on wire.
Okay. All right, let's move on. What are we looking at?
Oh boy, that is a primary 12-volt power conductor that has been abraded through against some grounded metal point and is arc flashed and created a spark.
Oh, wait, English.
English? What you see is the result of a short circuit.
Short circuit. Okay, thank you.
5 words or fewer.
So what's causing this to happen?
In that instance, we primarily are going to look to abrasion of power wires against grounded objects, be they engine blocks or other things that have an earth case ground, or even another ground wire.
So this wire is rubbing with the motion of the boat and the vibration of the motor, rubbing, and at some point it just rubs through the jacket, and now there's copper that's exposed, touching whatever rubbed through it.
Yep.
So that is overcurrent protection. So let's talk about how we defend ourselves against that. Whoa, wait a minute, what?
I believe that's a Boston whaler, and being an outboard, we can fairly well decide that that is a fire on a boat that was caused by a shorted wire. The wire shorted, it got red hot, it caught the insulation on fire, and poof. Fiberglass is amazingly flammable.
All right, so that's a good example of overcurrent protection not functioning properly.
Or being
Let's talk about, or being absent, which is another good point. So let's talk about what we're looking at here. A lot of our car stereo guys like to use car stereo products because they're already in the store, they're familiar with them, and hey, they're beautiful to look at. So let's talk about that for just a moment.
Yeah, there's a couple of things going on in this image. All three of these items are purportedly marine products. The things we've got issues with are on the left one, the circuit breaker. You've got set screws that are directly impinging upon the wires that go into them. And that is a no-no per the U.S. Coast Guard and the American Boat and Yacht Council. In the middle example, we also have set screws that look like they're designed to impinge directly on the wire strands. But additionally, that fuse holder is capable of holding a type of fuse which is not ignition protected. And we'll get into ignition protection in a minute. And then the third example is a fuse holder that is an AFS fuse holder. And in all of my research, I have not been able to find an AFS type fuse that is, again, ignition protected. So in an environment where we have a flammable vapor present, say you have a fuel leak, we want to make sure that we're using ignition protected components so that a fuse doing its job and opening and breaking a circuit by creating a spark, we don't want that to cause an explosion.
So if I use a car stereo type non-ignition protected fuse, I can actually run the risk of causing an explosion.
Yeah, and ironically, it's causing an explosion by having a part that you installed do its job.
So I think that's all right. No, that was the next slide. So not even the kicker car audio fuses are ignition protected.
Correct. Yeah, that is an AFS style fuse, and that is our AFS fuse holder. And I've actually installed over the years a few of these in boats. And looking back, I realized what an issue that is if at some point these boats end up with some sort of fuel leak that can create a flammable vapor scenario.
Okay, so tell us about this.
Haha. That was an interesting Saturday afternoon. I actually took that photograph. That is a boat burning to the water line as a result of an explosion in the engine compartment. And that's on my local lake. That picture was actually shot from a friend of mine's dock. And I got to witness that thing. I got to hear the boom. I got to hear the driver spit out a few profanities, throw his cell phone towards the shore. He didn't get it to shore. And then he jumped in and the boat floated off and burned to the water line.
So he was okay, but clearly his boat was not salvageable.
He was lucky that he was okay. Many times a boat explosion can really do damage not only to the boat, but the person involved.
Side note, not about a boat, but when I was in high school, I was going to a tech school to study electronics. And in the parking lot of the tech school was a car on fire. And the people were just watching it, of course, waiting for the fire truck to show up. And I was talking to the guy that owned it, and he said, I don't think I fused my audio system. And this was before I was really into audio. Looking back at it, that's exactly what happened, is he'd put in a badass stereo, but he didn't put in a proper fuse. Now you take that to a boat, and it's a whole nother level.
Right.
So let's talk about these acronyms that I still can't remember what they mean.
This is going a little bit further along in the context of ignition protection. In the marine world, there are two common specifications we see. One of them is it's an American thing. It's SAE J1171. That's a test protocol that helps a person identify and test for ignition protection features. And then your ISO 8846, that's an international standard. In general, we look to ignition protection as being capable of doing two things. In the images you see down here, we've got an MRBF fuse, we've got an alternator, we've got a starter, we've got a bilge float switch, and we've got a trim pump. In the case of the MRBF fuse, that fuse is designed to be completely hermetically sealed so that in the event of a spark, there will be no flammable vapor inside of the fuse to even create ignition. Then, when we look at the alternator, if you look at that picture closely, you'll see that there's a fine wire mesh. What's going on with that alternator is in the process of doing its job creating electricity, if it creates a spark that can ignite a flammable vapor, that flammable vapor will burn completely inside of the alternator, and the wire mesh will remove enough heat from that flame so that it does not ignite the vapor outside of the alternator.
Wow.
So when we talk about ignition protection, there's two things. You either completely seal the spark or you prevent the flame that it creates from going past some barrier.
Okay, so these are products that OEM boat builders are using on a regular basis, but some of the aftermarket guys may not be aware of all of this that's going on.
Sure.
Is there a?
Go ahead.
Go ahead. I was just going to say, is there a source for a guy who's doing it himself at home, or a guy who wants to get into this professionally? Is there a source of information that we can direct them to help them with all this stuff?
Well, this document for one, of course. The Coast Guard publishes a boat builder's handbook, and that is readily available online. If you go out on the internet and just do a search for U.S. Coast Guard Boat Builder's Handbook, you can find this. And in particular, you want to look for subpart I of the Boat Builder's Handbook that relates to marine electrical systems.
And this is what you use when you're designing our accessory products as well as our audio products.
Yes, this book is very thorough. It talks about isolating components from flammable vapor areas. It talks about proper wire gauge to use to minimize your voltage drop. It talks about overcurrent protection. It talks about everything involved with the marine wiring and electrical system.
You brought up a good point, actually, and I forgot about this last time you and I talked about this, but we make a multi-conductor in a single jacket that does speaker wire as well as LED control. That is a little on the thick side, and sometimes in training people say, Aaron, why is this so thick? It's kind of difficult to run this in some boats. Can you address why our multi-conductor is as heavy gauge as it is?
Yeah, you bet. You're talking about the RGB 150-foot speaker wire and the RGB wire, right?
Yes, sir.
Coast Guard law for boat builders building new boats tells us that in a sheathed multi-conductor bundle, boat builder can use no smaller than 18 gauge cables in a bundle. In fact, for boat building in general, in a sheathed bundle or individually, a boat builder cannot use wire any smaller than 18 gauge. We see other folks in the market who have 20, 22 gauge RGB wire. A boat builder can't legally, by law, use those cables in the production of a new boat. And as ABYC members, we're of the mindset that, man, if a boat builder can't build it that way due to federal law, we shouldn't sell stuff that a boat builder can't use.
So for the do-it-yourselfer, they can get by using the smaller strands, but if they want to do it properly, best practices, they really should be using the heavier gauge, even if it provides a little bit more of a challenge in terms of running it.
That's correct, and there are other benefits involved too. When we get into that real small RGB wire on a lengthy long run, you get enough voltage drop that on that last light you connect, if you're doing a leapfrog wiring system, as it were, you'll see brightness diminish, you'll see colors go off. So it's just better to use as much copper as you can to keep our voltage up as high as it can be.
Excellent. Moving on. So what's this?
Aaron, that is our new KMFMF master battery fuse holder. and the associated MRBF fuse. I see you have them up.
Yes, I'm doing the manual zoom.
All right, these are available now from Kicker.
So what's special about this? I mean, obviously to a car stereo guy, this doesn't look like anything we've used before, and this doesn't look like anything I've ever seen before. So what do we need this?
Coast Guard law, again, this is for new boat builders. And to look at our background, my background, historically, we said a fuse or a circuit breaker needs to be, within 18 inches of the battery. Well, the Coast Guard mandates that for new boat builders that overcurrent protection be no further than 7 inches from the battery or from any distribution point. And we can put this in kind of a logical, that makes sense term. If you think about your typical battery and how far apart the positive lug and the negative lug are, you think that's about, guess what? Kind of like near 7 inches. I think that the Coast Guard's intent, I don't know this, but I think their intent is that you've got overcurrent protection placed on a positive voltage wire in such a manner that if that wire shorts against the negative terminal of the battery, that your overcurrent protection will pop.
So it all comes down to the distance between the posts on a standard battery.
I can't tell you that for certain, but I believe that's probably the thought rationale.
As smart as you are, Phil, I'm going to go with that.
Okay. So with our KMFMF holder, it's a neat design. The tang to the right in the image is designed to mount literally right on top of the positive conductor of your battery. Then your fuse connects to the terminal stud, and then your crimped ring is placed upon top of the fuse, and then it's all snugged down with a nut driver or a wrench. That literally is putting your overcurrent protection, your fuse, right at the battery.
Now, I know there's some car stereo guys with big light bulbs going off. Hey, could I use this in a car audio install?
Absolutely. We offer that fuse from 40 amps up to 300 amps. They all fit the same physical parameters. So, yeah, the answer is yes. Use them wherever you want to.
Excellent. Now, if I need to replace a fuse, if I'm not near a Kicker marine audio dealer, car stereo dealer, where can I find this fancy looking fuse?
Well, despite the fact that until today, most people have never seen this fuse before, it is very readily available. You can go to Amazon and look at MRBF fuse and find several people offering them. You could go to a marine electronics retailer such as West Marine and find them on the shelf. You can also obviously go to your local Kicker marine audio installer who soon should have these on his shelf.
Very nice. What's this?
These are our new marine distribution blocks. On the left with the red knurling knob, that's our KMF fused DB3. It's a 1 in, 3 out fused distribution block. And then the item on the right, go ahead, Aaron.
So I was going to say, so for those of you with large enough screens to see this, this is the input with the fuse installed, and then the 3 outputs. And so these are all individually fused, headed out to wherever it is you need them to go.
Yeah, if you guys would want to, on your PowerPoint slide screen, zoom in, and we can kind of describe, if you look at the left image, the first lug to the left, the stud is electrically connected to the strap that's common to all 3 outputs. But then what happens that makes this whole thing work is that the studs for the 3 outputs are not electrically connected to the strap that is the base. In fact, there is a plastic ring around the bottom of each of those studs that electrically isolates the strap from the stud. The fuse, when you install it, makes that connection from the strap to the lug.
Ta-da! So Phil, on the top of this, which you probably can't see on the PowerPoint there, is it says maximum torque 100 inches per pound. What's that about?
You don't want to twist the stud out of the plastic base. So our engineers have gone and said, okay, what's it take to tear one of these up? And they printed it on there just so we're all aware.
So again, best practice is to use a properly set torque wrench to tighten these down.
Honestly, I think most instances we're not going to require a torque wrench because that's a max torque spec just to prevent mechanical failure. In my history with similar style fuses, our guys are going to know what wrench tightness is appropriate.
So if you're Richie Holtzman, you need to get out the proper wrench, torque wrench. But for the rest of the world, just a regular wrench. Just be delicate.
Wow, that's a zinger, Aaron.
Richie, I hope you're watching because I love you. So what's this?
Oh, just quickly touching on it. I know a lot of guys out there will prefer to use a thermal breaker rather than a fuse, and I can't really fault anybody for that. Our one word based upon, this is best practice presentation, make sure you use a good breaker from a good company. And just anecdotally in passing, Blue Sea Systems, another brand, we don't sell their stuff, but if you really want to use thermal breakers, look for the Blue Sea Systems brand. They're the gold standard out there in the field.
One of the challenges you run into in the car audio world, as you know, is circuit breakers are very convenient, but if you pop a 100 amp, 200 amp circuit breaker under your hood and you just keep clicking it back into position, you're not fixing the problem. And that can lead to a catastrophic failure down the road. So that's one reason we're always a little bit hesitant, even in car stereo, to use circuit breakers, because we just don't know the competency of the person who keeps resetting it and then driving down the road. So I'm sure that's very similar in a boat application as well.
That's true, and there's at least anecdotal evidence that tells us that as those thermal breakers pop, their current rating can change, and change upwards. Can they handle more current? Change downwards? Can they handle less current? Who knows which is really going on, but key to that understanding is they change. A tripped breaker may not be providing you the level of protection that ultimately you need.
And a fuse, consistent every time.
Yep, because every time you pop one, you've got to put a new one in.
Excellent. Moving on. What's this mess?
Oh, well, that's a mess.
Wait, before we give it away, let's ask the savvy folks out there. These are your signal cables, and they are running from the source unit over here somewhere, and then they're running down to these amplifiers. Why is this bad? Why do we not want the signal cables, or any cables for that matter, running down to the amplifiers? Let's give everyone a second or two to go, oh yeah, of course. Go ahead, Phil.
What's water do whenever you put it on a cable? It runs down too, right, Aaron?
It does.
This picture was lifted from a marine audio forum, and to the installer's credit, this was an in-process image of an install being done. He fixed it in the final iteration, but had he not gone and fixed that, what would happen here? Water gets everywhere, and it can come from splashes, it can come from rain, it can come from a leaky cup holder, it can come from condensation. And had this guy not addressed this, he ran a real potential of enough water getting on his signal cables that they would run it down due to gravity to the end of the cable and into the amplifier. So in terms of best practice, we would like to advocate that always your wires come from a location below your electronics and up so that the water doesn't run into your electronics.
A drip loop.
A drip loop.
So looking at this source unit, specifically, how do you achieve this in a real world installation?
A couple of ways. Of course, running your wire from below up to the unit is certainly the fail-safe way to do it. If, however, you've got a bundle or a harness that comes over from the top, just leaving yourself some extra wire so that you can manually bend in the U-shaped loop. That'll help keep water out. As the image shows, you're going to shed that water at the lowest point on the wire.
Anybody notice this is Mr. Steve Irby's source unit, and it's got his helm art on there. Google Moses Live, and you'll see Mr. Steve Irby's album. We've got one here in the museum. It's pretty cool. What is a dual battery system?
Well, okay. So many boats these days come with just a single battery, but some of them come with multiple battery systems. And boat builders they're in a habit of using a thing called a battery switch, as we show that Aaron has in his hand and as shown in this image. Battery switches are interesting on a multi-battery system. It requires intelligence and thought to use them properly. That's the best way to put it. And I look back to time spent in Party Cove, and I think about, towards the afternoon as I realize my battery is dying and I switch to the other battery. I might just maybe had a couple of adult beverages.
No.
And no, using a battery switch requires an understanding of what it does and how it works, and then you've got to use your brain in an active mode to set it properly. Additionally, battery switches can really do damage to your boat. Okay, so you run down a battery, you've gone to your other battery, you started the motor, and in the process of switching your battery switch, you accidentally managed to switch the switch to the off position, as shown in this image. But it's a high chance that you have fried a diode in your voltage regulator on your alternator because you removed the battery load from the alternator. And that's going to cause you all kinds of electrical problems that you got to fix on the backside.
So
now whether you use the battery switch, well, that could be, and you're replacing an alternator or a voltage regulator, you're replacing electronics.
Okay, so don't do that.
Yeah, if you choose to use a battery switch when you're doing a multi-battery system, no matter how many beers you've had in Party Cove, don't switch to off when your motor's running.
Phil, have you ever done it?
I'll plead the fifth, Aaron.
That was a dramatic pause. Okay, so personal experience, Phil talking here. Do not switch through off.
Yes.
So ACR.
Automatic charging relay. These are the things to use, and in fact, they perform the same function as a battery switch, but they do it automatically. Your ACR keeps the brains when you've lost yours. It does all of the isolating and combining based upon whether there's a charging source or not, and it does it automatically.
So it's a little bit more money?
In some places, it might be a little bit more money, but in general, I think you're going to see a battery switch at $59. Your ACR is going to be about $59.
Oh, wow. So there's no choice, really. Just buy the better one.
Yeah, you buy the thing that does what the battery switch does, but does it automatically.
All right. So here's an example of setting up a dual battery system. Can you walk us through this?
You bet. On the right side, let me just look in here on my trifocals. On the right side, a battery called Stark. That's going to be the battery that comes in your boat whenever you buy it, whether it's got amplifiers or not, if it only has one battery. Then on the left is your house bank, and it's typical on a big marine stereo to see two batteries, like a Group 27 wet cell, probably not ever four, but the application's still the same. You can hook your audio system to your house bank. It will run off of the big dual battery, the house bank system. The battery's on the left side, and it'll leave your starting battery on the right intact. Then when you start your boat, the ACR combines, it runs them all in parallel, and everything gets charged.
So again, this is the best practice for doing a marine audio system if you want to be able to get home at night.
There you go.
Why don't we use one of these?
Diodes. This is a device that's been in the market for several years. Some folks have used these in car audio systems. It's a diode-based battery isolator. The reason we really don't want to use these in the marine world is we're spending a lot of time parked and playing stereo and not running the motor, which is different, I think, for a lot of us when compared to driving our car and listening to our car stereo. A diode-based battery isolator loses voltage as a function of its operation. 0.7 of a volt typically is lost going through that diode. So instead of charging at 14.4 volts when your engine is running, you're going to be charging at 13.7. You're losing almost a full volt through that device, and it's for that reason we don't want to see those in boats at all.
All right, more best practices. Start in reverse. Say, what? I'm running a 10K. You want me to run backwards?
Excuse me a second. It's just a cough. Seasonal allergies. Yeah, I actually have a piece of fiberglass here, and I prepared this yesterday. Fiberglass is made up of 2 layers. You've got your base layer of actual fiberglass, which is a pretty tough and rugged and durable product. But on a boat, the surface that you see is actually a separate product called gel coat. And unlike the durable, tough fiberglass underneath it, gel coat is amazingly brittle. And so when we're cutting it with a hole saw, when we're drilling it for mounting screws, it's always best to start our tools in reverse and more or less abrade through the gel coat layer down into the fiberglass. It gives us a smoother cut, gives a cleaner edge to the cut hole or the drill hole, and it helps prevent cracking. Now I'm going to try, see if I can get this up here close. The image there is of 2 drilled holes. The left one is a hole that I drilled with the drill bit going forward, and you see how you've got a nice jagged edge. And then the right hole was drilled with the drill running in reverse through the gel coat, and then turned around and switched to the forward direction to drill through. And I think everybody can see how different those 2 holes look.
Yeah, that's great.
So that applies to drilled holes. It applies to holes that you would cut with a cut saw for your speaker mounting. It's best practice.
Cord surfaces, obviously very common on a boat, and you've got some very specific advice on this as well.
You bet. And these 2 images on this PowerPoint actually show 2 different things, but we'll get to that in a minute. Here we have a cord sample. This is a piece of deck section. If you look closely, you can see that that's actually plywood between the top and bottom layers. Boy, this is tough running the camera in backwards. There's a good shot. That cording material is often through drilled. In this case, this was where a stanchion was mounted, but your manufacturers are actually pretty darn bad at this. They'll leave this drilled hole through the fiberglass top, through the plywood, through the bottom. They'll leave it exposed so that any water that gets in through that hole can rot away the wood. In general, if we're going to be cutting or drilling through a cord surface, we want to take steps to protect that wood. So in the left image, we can see that we've drilled a hole, and then the middle portion of that image, there's a graphic representation of somebody who's gone in to the bottom side, applied a layer of tape, then filled that freshly drilled hole with epoxy. And you let it kick and cure and solidify. And then on the third portion of that image, then you can see that they have re-drilled through the epoxy the appropriate size screw hole so that their fastener is going through the open portion of the cord decking, but it's going through a cylinder of epoxy rather than going through the wood, so that if water gets through there and starts leaking through where that fastener is attached, it's not going to get to the core and rot the core. Then just real quickly, on the right image, if you study it closely, you can see that in fact, the top skin and bottom skin are still intact and in place. In this image, the author who did this picture used a Dremel and a rotary tool, and he carefully removed some coring between the top skin and bottom skin, and then he did the epoxy fill and redrill. In that instance, he was needing not only, he needed to protect the core, but he also wanted to keep the structural integrity of the top skin and the bottom skin so that he wasn't relying on the adhesive property of the epoxy to hold it in place.
So we're kind of in the weeds, but this is important because at this level of installation, this is the best practice, and it's definitely going to take some more time. So if you are going to a professional shop and the quote for labor seems a little high, it's because they're doing this. This is the kind of work at the level they're doing. And if you're doing your do-it-yourself system at home, you also want to be sure to maintain a proper level so that the expectations that you have are met, not only by the product, but by the quality installation. Because just like car stereo, the best product in the world is limited to the quality of the installation. And obviously the integrity of the boat is primary in all of these applications.
Yeah, probably for this audience, the most common place where we're going to see the need to do this is going to be, for example, on a transom where somebody's putting a remote for their stereo. You're going to run into a cord material there, and your liability for your consumer, you need to take steps to maintain the structural integrity of their boat. So doing this is the right thing.
Very nice. Countersinking. Let's talk about this for a moment.
Yeah, you bet. This goes back to the whole gel coat is brittle thing. In many instances, say for a speaker, we cut our speaker hole and then we drill our mounting holes, but we're drilling through gel coat. And I went ahead and prepared this yesterday as well. Let's see if I can do this and show this. I've got a couple of small holes that are designed for a screw to be installed, and pretend this is a speaker screw. This screw right here, whenever I go to screw it in, the threads of the screw are actually going to grab that gel coat and they're going to lift it and crack it. However, if I go to this hole that I prepped with Countersink, you can see that I have removed a diameter of the gel coat that prevents the screw threads from actually grabbing that gel coat, and the screw will actually drive in, and it'll drive in and sit down flush on top of that gel coat. Hopefully you guys can see that. There,
Yeah.
there's good.
Yeah, it's good.
So countersinking is just, it's a nice way to ensure that the work you're doing doesn't end up causing you to have to come in and have a fiberglass repair guy come in and fix damage that you did as part of your installation work.
Butyl tape.
Yeah, this is, again, we're kind of in the weeds and we're way off electronics at this point, but here's my 5 or 6 year old roll of butyl tape. It's flexible rubber sealant. And the best brand that I found out there, again, we don't sell this, but there's a guy out there who sells this stuff. And his brand name for this stuff is bed-it butyl tape. You can look for it online and find it. It's great stuff. What's really nice about this, other than like 3M 4200 or 3M, all the squirty gooey stuff, you can flex it, play with it, stretch it, bend it, and it stays flexible forever. And it is a super good sealant. If I go with my screw here and put a little bit right underneath the head of the screw before I go and tighten the screw, so I get, just a dab of this stuff all the way around. Whenever I go to screw that in the hole, that sealant will go into, ironically, the countersink that we installed, and it basically will form a permanent little O-ring for you. It totally prevents water from ever getting through that screw hole.
I'm suddenly thinking about guys that paint houses, and they will tell you preparing for painting takes a lot longer than the actual painting does. And that's kind of what you're saying here, is it's all the prep work that makes the details. And it adds time, but it certainly makes it the best possible installation.
Hey, Aaron and Phil, just wanted to give you a heads up. You're 10:48 right now.
Oh, okay. Thank you.
Sure.
Thank you. We probably ought to jump into some questions.
They say they have other calls to join.
Oh, okay. Okay. So, oh, go ahead, Phil.
No, just a quick last image. There's our, of course, our cord through hole with a bolt with countersink and the butyl tape applied, and even loosened and lifted up like that. That butyl tape is still sealing that hole. So, guys, in my world, I use this stuff all the time. I'd say make it a point to look it up and start employing some sealing materials like butyl tape in your installation work. It'll keep the boat drier.
All right. Ken, since you just jumped in there a minute, do you have a question that keeps coming up that we should address live on air?
Not a question that keeps coming up, but Adrian Gray asked if Kicker's speakers have a specific watertight rating, ISO 12216. Phil, maybe you can address that.
Kicker speakers, yes, have now been certified ISO 12226. For those that aren't aware, and boy, that's getting way in the weeds, that's a certification spec specifically relating to portholes, hatches, doors, and windows on boats. In the event of a capsize or submersion, those hatches, windows, and doors are designed to keep water out. Similarly, Kicker speakers are certified in the event of a capsize to not let water into the inside of a boat.
So, Phil, is this something that's required for new boat construction?
It is not currently required in the U.S., but globally it actually is. And so, yes, we are one of two brands that carry that ISO spec.
Wow. So internationally, we're the go-to.
Absolutely.
And we have another question from Leon. He said, should I replace all the wiring in a boat that's been sunk?
Wow. Man, probably so. Although that's a big job. I probably would be talking with my insurance company before I embark on that. It may be a total.
But if maybe if you were to buy a boat salvage or something like that, best just to rewire everything.
Yeah, even wire that's been wet, especially in a salt environment, you're going to have corrosion and you can't rinse it out.
Yeah.
Can you discuss the differences between SAE and AWG wiring standards?
Aaron, do you have that? I'm
No.
not fully up to that topic, to be honest.
No, I am not. I'm not up to date on that. Hey, Ken, get that gentleman's email address and we'll get back to him.
Here you go.
Will do. Hey, Phil, do you have a suggestion for making an existing speaker hole larger, i.e. if the existing OEM location was smaller than what you would like to install in the aftermarket?
Yes, this is kind of tricky, but utilizing stacked cup saws, often you can mount the existing cup saw that fits through the hole, and then over the top of that, put your larger cup saw and then assemble that whole system. The smaller in front cup saw will guide the larger back cup saw, and that'll help you get that hole started. Barring that, you're going to masking tape it, draw it out, and use a jigsaw.
Clever. Ken, any other questions we should address?
I think that's all I see. If anybody else has any questions, feel free to ask. Steve is asking, Steve Labby, you're asking, where does ABYC come from and come into play?
The American Boat and Yacht Council is what we refer to with the abbreviation ABYC, and that is a group of engineers, boat builders, boat manager, owner type people, and they take the basic U.S. Coast Guard safety law guidelines for new boat construction, and in some areas, they add additional requirements. Now, this gets kind of confusing, but the ABYC writes the standards book, then a boat builder who is actually an NMMA member, National Marine Manufacturers Association, Your NMMA member boat builders build their boats to the ABYC specifications as outlined in the ABYC standards. So a little bit confusing, two different groups, two different membership fees, but one feeds upon the knowledge that the other provides.
Are you saying that all ABYC compliant installs are NMMEA compliant or vice versa?
NMEA compliant
Right.
or NMMA compliant?
NMEA compliant are always ABYC or vice versa?
Well, we're really in
Is
the
one
weeds on this.
larger than the other?
The NMEA really doesn't speak any at all to best practice as it relates to wiring, overcurrent protection, sizing of wiring. The NMEA is more involved with CAN bus communication between things like multifunction displays, chart plotters, and in our instance, radios that are NMEA compliant, like our KMC5, which can be controlled on a NEMA CAN bus. Hopefully that makes sense, Ken.
Okay.
ABYC writes the rules that the boat builders have to use, and then NMEA is a separate thing.
Okay, in terms of wiring certification specifically, when does ABYC come into play?
In general, in terms of wiring specs, the ABYC pretty much toes the line exactly with what is written in the Coast Guard law. There's just almost nothing with regards to wire labeling, wire size, thermal capacity of insulation, fuse distance, and all of those common aspects that relate to boat wiring safety. Coast Guard and the ABYC are the same.
All right. Is there a list of tools that you would recommend for doing marine work that maybe we could provide, or maybe 4 or 5 that you could shout out that somebody might want?
Man, you know what, Aaron? I think we messed up not having our crimper available to show guys.
Oh, yeah, that fancy crimper.
I use a hydraulic crimper these days for all of my ring terminal connections. That would be the #1 tool that I would recommend everybody go out and get if you don't already have one. Other than that, a good quality wire stripper, not the cheapy thing that you find at the auto store, and a good crimper. And ideally, I typically have one tool that I use to strip wire. I have a completely separate tool to crimp wire so that I know that I'm getting a good crimp. And I guess the other key thing too, those crimps need to be done with heat shrink connections. So after you've done the crimp, use your hot air gun and shrink that plastic over your wire to connection joint.
A couple people have asked if this webinar will be available for later rebroadcast. Their answer is yes.
Yes, correct. Thank you.
Could you make a list of those tools for the future that maybe we could put on the Kicker Tech Force section of kicker.com?
I think that's an awesome idea. We probably
good.
need to provide links maybe.
Yeah, yes, the answer is yes, we can do that.
Are there courses that you recommend?
Well, I would say there's no recommendations right now. Let me look into it. Most of the NMEA training is going to be talking about engine systems and electronics installation. It's outside of the scope really of what we do. So I'd have to look into that before I knew the firm answer to address that question.
Let's get an email address, Ken. We'll get back to that gentleman.
Yep.
All right. Ken, unless there's something else pressing, we have hit our time limit. And as Ken pointed out, you'll be able to watch this webinar again. Tomorrow, you're going to receive an email, and there'll be a link to that video. In addition, we're going to ask you to give us some feedback. What did you like? What can we improve? Also, what do you want to see in the future? Hi. Oh, hey, Bart's got that fancy crimp tool. Oh my God. Hold on, we got this just in. If you're still online, take a look at this. Look at that tool right there.
That's
So
not a
Phil,
real expensive tool for sure. You can buy better ones out there. That's the one I picked up just to play with, honestly, but I actually enjoyed using it. That was about $40 on Amazon.
comes in a nice case, and it's got a bunch of different size crimps in the case. And if you're looking for it on Amazon, it's hydraulic crimping tool YQK-70. So you'll be able to re-watch this webinar. You're going to get an email tomorrow. Please respond to that email and give us suggestions, what you'd like to see in the future, also what we did well and what needs improvement. Aside from that, kicker.com, go to the tech site, and we've got a bunch of white papers, videos to watch, all sorts of additional information. Phil, thank you so much for your expertise today. We do appreciate it. And
Thank
our
you.
audience, thank you all. We'll be in touch.